What if there's radicals on both sides? Whatever. All you need to do is you wanted to isolate the radical. We've isolated the radicals. They're both isolated. Awesome. So just square them. And then they go away. Nothing happens to the insides. They're just gone. Hey, now we've got x's on both sides. Let's get them on the same side. I'm going to move this x over. So we got 2x minus 17 equals 21. All right, we're going to add a 17 to both sides. We get 2x equals 38. Divide both sides by 2. We get x equals, let's see, 38 divided by 2 is 19. And then 19. Okay, I want to do a check, make sure that that works out correctly. So we've got 3 times 19 minus 17. That's getting square rooted. We want to see if that equals the square root of 19 plus 21. Well, that is the square root of 19 plus 21, so that is 40. This is the square root of 3 times 19, which is 57. And then 57 minus 17, hey, that's the square root of 40. I don't know what the square root of 40 is, but they're both the same, so we're set. That works out. Sweet. Now, final question of the day is there's this thing called an extraneous solution. We've seen them a little bit, like back in some of our earlier chapters when we were talking about like rectangles. We were solving quadratics with a rectangle and we got a negative side length. That's what's called an extraneous solution. One that works in the algebra but might not necessarily actually work for our problem. These ones are extra special because it's not that we're working with a rectangle, it's we worked our way all through the problem, we followed our algebra correctly, but our algebra actually spit out a bad answer. Before when we were doing the rectangles, our algebra worked, our algebra spit out 2 good answers, but in the context of the problem, didn't work. Extraneous solutions, it's just pure algebra, and when you do the algebra, you get an answer that doesn't actually work. It's an answer you can't quite trust. So watch this problem. We're going to start, we got to get rid of that radical. Well, we want to isolate the radical. That's already been done for us. You're welcome. So we want to get rid of that radical. To get rid of the radical, we're going to square both sides. We get 6 minus x equals x squared. And now we've got a quadratic. The ones we've been doing up to this point have been linears. So we got x by itself. This is a quadratic, something we did a lot back in chapter 10. So we want to get this thing equal to 0. So I've got 0. I'm going to add an x and subtract a 6. I realize that's more work, but I really like when my squared term is positive. So I am going to get everybody with the squared term. Add x minus 6. Okay, now that's something that we can factor. So I'm going to set up, I'm going to just do this one kind of in my head. You can also box factor this one, but you might be getting pretty pro at factoring at this point. I need factors of 6 that subtract to be 1. That's going to be 3 and 2. I'm going to put a positive on the 3 and a minus on the 2. If you're not quite sure how to factor, pause the video right now and do the box factor, and you should end up with those 2 answers. Moving on, this thing equals 0. So x equals negative 3. And the answer for the other one is x equals 2. Okay, so it looks like right now I've got 2 answers to this equation, negative 3 and 2. However, check what happens when we start going after the answers. If we put in the 2, I'll do that one up here. So we get square root of 6 minus 2 equals 2. and we get the square root of 4 equals 2. And the square root of 4, yeah, that's 2. Yeah, that checks out. Watch the other one. We get square root of, oh, got ahead of myself. Undo, please. Thank you. 6 minus negative 3 equals negative 3. 6 plus 3, because we got a minus minus, so that's 6 plus 3, so that's the square root of 9 equals negative 3. The square root of 9 is 3. Last I checked, 3 and negative 3 are very different numbers. So this is extraneous. So that is an extraneous solution. Negative 3 is not an answer to our problem. Our only answer to this problem is x equals 2. That's our only answer to this thing. The negative 3 is extraneous. It's a bonus answer that the algebra spit out that we don't want. That's it for our notes for today. Remember, if you need to solve with a radical, your first job is to get the radical by itself, then square to get rid of your radical. After that, you want to do other solving steps, either with linear or quadratics. Thanks for watching.